Okay, good morning everybody. My name's David Whatoff. I'm the Development Manager within SOYL, and certainly with the change of focus on this morning's meeting, I've been trying to look at ways demonstrate ways which soil and the precision farming can help improve nutrient utilisation, and ultimately looking to maximise the crop's potential. Many of you will have seen in the news, and there's definitely moves afoot in Westminster, that the whole soil health and fertility is very much on the tips of their lips. And my concern is that they call it a crisis. Well, truly it's not a crisis if the soils are well managed. It can be a crisis if some of the basics aren't taken and grabbed hold of. So what I'm going to do over the next few minutes is just explore about how nutrients get into the crop, and what happens if one or two things along the way impact that in terms of compaction or availability of nutrients is reduced, and looking at ways which we can improve on that. So one thing which you'll begin to hear more and more of is this phrase called nutrient use efficiency. And in very simple terms, we have a bag of fertiliser, we have a crop outside, and one goes with the other. And you're putting the fertiliser on to maximise plant growth. And ultimately, within the journey of that fertiliser, it gets applied to the soil. Some of it will either volatilise or be eroded, and some of it will leach. But you're aiming for the majority to be taken up by crop. And the higher your crop yield, the more your nutrient use efficiency, the higher it becomes. So typically, if you've got a really good, well-grown crop within nitrogen, you can look at NUE efficiencies of sort of 70%. But if you damage the soil or your soil health becomes impacted, then those figures can come down. And if you think, well, those bags of fertiliser we're leaning against, if only 40% of that is actually growing the crop, then if you think of it in those terms, then it can be quite an impact. So what are the factors which affect nutrient use efficiency? Well, they fit very nicely with the tenets of soil health and what is soil. You've got the three main elements. You've got the physical, the chemical and biological aspects of soil. So from a physical perspective, we're talking about the soil texture, the soil structure and the soil depth. This nicely encompasses what it should potentially look like, where you have soil particles interspersed with a little bit of water, but crucially with air spaces in between. You're looking for a mix of 50% of mineral, 25% moisture, 25% air. This allows for the plants, the microbes, and the soil to function correctly. The nutrients we're applying, be it the P and K, they need to adhere to something to sit within the soil profile, so they are made available through the water, through the soil solution, to the plant. And when you're looking at the chemical properties, you'll notice that they tend to be positively charged, and this is because the clay particles are negatively charged. So back to GCSE physics, you've got a negative magnet and a positive one, they attract each other. And this is what's happening with the nutrients, and this is why they adhere to the side of the clay colloids. You'll also notice within here we've got some organic matter, and organic matter really is the farmer's best friend. And from a sustainability point of view, we really need to consider how we can look to manage that moving forwards and how we can look to utilise that. And I've got a couple of slides which really demonstrate the importance of organic matter. And finally, we've got the biological aspects of soil. These are quite often misunderstood, and a lot of people will say, well, I've got lots of earthworms. Well, there's so much more to soil biology than just the earthworms. And it's the microbial activity and also this mycorrhizal fungi, which also help add an opportunity for the soil to break down the soil, give nutrients into the soil solution and maximise the plant. So getting all these factors correct or optimising with them in your soil will nudge up the ability to utilise the fertiliser which you're applying. So let's bring this down into a little bit more detail and look at some of these physical soil properties. One of the best things to do, and indeed we'll do it in a little while, is to dig a few holes and have a look-see. We need to look at the soil structure. We need to see that the structure is made up of various sizes of soil. You need some larger aggregates to allow for large draining. You need some finer aggregates so that the roots, as they go through the crop, have got a large surface area to be able to pull up nutrients. So digging a few holes is really a good idea to get a handle on what's going on in the soils. From a precision agriculture point of view, one of the best ways of doing this is to do it in a much more targeted fashion. We've got a method which is called EC survey, which allows us to determine on a map where the textural changes are within the field. So here, using this sort of detail, instead of just having 3 fairly sporadic holes, I could focus very closely on the yellow, the dark brown and the orange and get a real understanding on how the structure and the texture are working together. And if you remember in my first slide, one of the key factors are these elements working together. And from this information, we can then look more closely at what that texture is. We can do some texturing shortly. We can look at the organic matter closely. We can get an idea of what texture is impacting the organic matter and look at the structure in due course. Soil texture is a fundamental knowledge piece, and you really need to know where you're at with it. This is the information out of the back of the DEFRA Think Soils Guide, and whilst it clearly shows the 13 main soil textures which are commonly found in the UK. But it's interesting to look at it in a bit more simplistic detail of the different colours. So you've got the dark brown as your heavy soils, the orange as your medium soils, and your sandy as your light soils. These give you indications on how the soils are going to be able to hold nutrient, also give you an indication on how the soils are going to cultivate and how well they're going to till. So understanding the basic mineral properties by determining the sand, silt and clay is really a simple skill, but really helpful in being able to understand, well, really, this soil should be giving me more potential and then prompting you to ask more questions. Compaction is something which is often unavoidable, but best avoided at all costs, really. And to be able to measure this physical property is a really useful indicator, because different soil textures have different values when it comes to bulk densities and compaction levels. So to measure compaction and get an idea of that, it's very simple that you literally take a known volume of soil. This just happens to be a 100cc ring, and you just knock that into the ground. By the time you've dried it to let the effect of the moisture come out and the water and then weighed it, you can then determine what level of compaction you are and then compare this against this chart. So now you've got the skills of knowing what your soil textures are. You can then begin to read across and see where you are with your compaction levels. So you can notice on this chart we've got some levels here which are ideal bulk densities for plant growth. And in a very rough rule of thumb, around 1.6 for sand, 1.1 for clay, and loams as 1.4 as a bulk density value are the figures you're wanting to look for. But quite often when I get called out onto farm and we look at figures and you start to see figures in excess of 2, the infiltration is damaged, the ability for the roots to penetrate, the ability for the plant to pull up nutrients are all significantly hampered, reducing this nutrient use efficiency substantially. One of the best ways of preventing of dealing with compaction is preventing it, and just consideration on what your tyre gear looks like is one of the most basic and fundamental things you can do, certainly as part of your purchasing decisions if you're investing in new machinery. We've got 2 equally loaded trailers here. This one's on super singles and this one's on some nice wide profile tyres. They're both capable of similar sort of speeds on the road, but you'll notice the damage which is going on here, and you'll notice the lack of damage which is going on here. And this is all just down to a simple purchasing decision which can make a significant difference. Because while this damage is clearly evident on the surface, it's what's underneath which is having the impact. And underneath is where the roots are, and damaging deep at depth here is preventing soil moisture getting up and also allowing roots to penetrate down. So as your axle load goes up, with an incorrect tyre, you can soon get to a situation where you're putting down a compacted layer nearly 20 inches deep. If I then said to you, well, we need to do some subsoiling and we need to be doing it at 20 inches, you start scratching your head saying, well, David, my tractor won't pull it. So we've got to start just thinking about what our tyre loads are, what our tyre pressures are, and if we have the opportunity of making decisions, avoiding the compaction in the first instance. Trafficking also has an effect, and if you're looking at taking root crops off and the consistence of trafficking, the more trafficking which happens over the line, the more damage which is going down. It's effectively pushing the compacted layer further into the profile. And there's nothing worse than a really dense layer at depth to be able to look at. And sometimes perhaps the only way to cover that, to remediate that, is the use of cover crops and a much more long-term intervention process. The other key activity which is hampered when we have compaction is the microbial activity, because you're beginning to crush the pore space. If you remember when I introduced the physical properties, I mentioned air as well as water. And crushing that, squeezing that air out and making an anaerobic situation means that you're going to have a soil where the microbes can't function, they can't release nutrients, and they can't help you bring that. So if you've got a situation here, it's around 60% water-filled pore space, then you've got sort of an optimum situation. But if you go beyond that, and where the water is starting to saturate those pores, then you get massive denitrification, and you get a real reduction in the soil's ability to feed your plant. Moving on now, we've just looked at the physical, looking at the chemical soil properties. Some of these maps you've already seen from John. These are our PK, MG and pH maps. And we use these to identify the areas of nutrition which is in the soil. We do this on a grid basis. We take a sample every hectare, and using that information, that intensive sampling, we can very nicely colour up the areas of the field which have nutrient. Now, in this particular example here, we've got some very dark blue areas, which is sort of saying we've got some high 4s and 5s. As John was saying, a dark green is a 2+, and a light green is a 2, which is the optimum sort of size, optimum soil index. But in areas where you get some oranges and some reds, these are real opportunities for you to be able to build these areas and take these averages and be able to lift them. I mean, people say to me, we're looking at these soils, we've got some poor soil here, it's a very low index. The converse way of looking at that is perhaps that soil is so good at transferring the nutrient from itself to the plant that you just haven't kept on top of offtake, you haven't kept on top of feeding it, that being able to feed those areas more robustly will indeed give you the response you're looking for. So if you've got areas here which probably are 20% of the field and they're hampering performance, then they're areas which are worth consideration. We can also look at nitrogen uptake using satellite imagery or remote sensing imagery from a drone or a light aircraft, which allows us to see how much nutrient of nitrogen we're actually pulling up into the crop. And we do this with measuring something which is called LAI, or leaf area index. And typically, in wheat, 1 LAI is worth 30 kilograms. So once we have a map like this, we can determine how much nutrient has been pulled up into the crop and use that against our measures of nutrient use efficiency. So it's a really good factor in the spring to be able to take this information. In terms of being able to do something about it, many of you will be aware of the sort of the variable rate technology which is out there, and ultimately using the sampling and the maps, we can create the application maps which will put the nutrient in the right place. And remember, putting it in these areas of low performing, of low nutrients could well be a real key to the door for lifting yields as a field average. Biological soil properties are quite often under-discussed. And one of the major factors is the effect of organic matter. Organic matter effectively, to a large degree, is sort of the factory in the engine room of where the microbes break down, live, and indeed feed, and understanding the benefits of organic matter and the sustainability value of organic matter is really key. On a very simple level, organic matter has a really useful impact on preventing compaction within your soils. And this is a nice chart which begins to demonstrate this. So along the side here, we've got various tire pressures or pressures on the soil, and along the bottom here we've got some organic matter. So in low areas here, around 1.5 to 2% organic matter, then a 12 psi pressure is all that's needed really to begin to compact that soil. Whereas if you've got a 6 or 7% organic matter, then you've got nearly 3 times as much as resistance. And this is very much down to the springing ability of soil. And I've got some samples here. So these are some local soils which have been taken. And then this is some been intensely farmed soil. And you can see how much that just wants to be deformed. There's no effort or at all requirement needed for that to bounce back. But if you compare that to a high organic soil, then even putting the same amount of pressure on, whilst I'm firming it, it still wants to break up. And it's this effect in the soil which we're looking to utilise to best effect. Grab hold of my squeeze box, wherever it's gone, it's here. So, in terms of being able to understand where your organic matter is across the farm, we do a soil organic matter mapping. It's generally done when our P and K mapping is done, and we do what's called a composite for the field, because there's quite often just subtle differences really from one side of the field to the other, unless there's been a major management structure. But typically for about 20 pounds a field, we can give you an indication of what the organic status is of the field. Having a map of the whole farm with this information allows you to make a management plan in terms of how you're going to remediate very low areas and areas you can probably concentrate on in terms of importing organic matter or looking to use a management strategy to compensate for negative impact. The other element of organic matter is it gives more food opportunities for the microbes and the bugs. And it builds the soil carbon. It builds the ability for the soil to hold nutrients and also function and freely give to the soil. And ultimately, using this, building the organic matter allows this increase in microbial activity and gives you more bang for your buck. There's opportunities to enhance your microbial activity. There's various products out there. There's some mycorrhizal inoculants, which are like a fungi, which sort of grow with a symbiotic relationship with the plant and pull in more nutrients. And there's also some sort of phosphate solubilizing bacteria which help that. And this chart here nicely sort of shows the phosphate uptake when you're utilizing more use of microbes, getting their value. So we've been through quite a journey. Some of it's been a little bit sciencey, and I do apologise, and hopefully I've tried to make it as interesting as I can. But understanding that all these 3 major elements work in synchronicity with each other and not taking them in individual slices is a really important step to take to maximise the performance of your soils. And a way just to have an overview of this is the Soil Life Report, which we have. This allows us to look at these blocks of these major pillars of information and be able to see their interactions. So in this middle here, we're looking at the physical elements, we're looking at the texture, we're looking at the compaction and the bulk density, all the things I covered earlier. Here, we're looking at the microbial activity, we're looking at the major phosphates and potashes, the organic matter, and also the micronutrients. And on one sheet, we can begin to get a real handle on what the status of the soil health is in an easy and overview situation. So here we are, we've got the soil texture, we've got the bulk density triangle, looking at compaction and also porosity, and also pulling it all together and actually scoring what all these elements with a soil vitality index. So giving an indication of comparative indication between one field performance and another. So in summary, to maximise your soil potential, please do think about in terms of this nutrient use efficiency. Think, well, I've got a bag of fertiliser there. whilst I'm putting it on the soil, I want the plant to make as much use of it as possible. And to do this, you've just got some very simple things to follow. You need to maintain or improve your soil structure. Give the roots a chance to get down there and pull the nutrients out of the soil. Build the organic matter, help get the microbial activity really beginning to run. Ensure you've got an aerobic soil. Make sure that the microbes, that they can breathe and they can function correctly. Maintain the correct soil pH. Absolute basic and the fundamental. Develop your microbial activity as best you can, and then maximise nutrient and water availability. Thank you.